You can have a $1,000 sleeping bag. You can wear the most expensive merino wool layers on the market. You can build a shelter that looks like a fortress. But if you don't understand the second law of thermodynamics, you are going to freeze to death. Here is the brutal reality that most survivalists ignore. Cold is not a physical thing. It doesn't enter your body. Cold is simply the absence of heat. What kills you isn't the winter air invading your jacket. It is your own body heat escaping into the void. Right now, 90% of preppers are setting themselves up for a catastrophic failure. They are fighting the weather when they should be fighting physics. In this video, we aren't reviewing gear. We are breaking down the physics of freezing. We are going to expose the four invisible killers: conduction, convection, radiation, and evaporation, and explain why your survival gear might actually be accelerating your death. Welcome to the science of survival. To understand why people die in the wilderness, you have to understand the universe's favorite rule: entropy. Nature hates concentrated energy. Your body is a biological heat engine, running at roughly 98.6 degrees Fahrenheit. The winter air outside is a massive vacuum, effectively trying to suck that energy away until you reach equilibrium with the environment. In a survival situation, equilibrium means death. Most people treat insulation like a shield. They think, if I wear this heavy jacket, I am warm. That is a lie. Insulation does not create heat. It only slows down the rate at which you lose it. If your metabolic furnace goes out, that jacket is nothing more than a body bag. Heat escapes the human body using four specific highways. If you block three of them but leave one open, you don't just get cold. You enter the early stages of hypothermia in under an hour. Let's look at the first and most common killer. Let's talk about conduction. This is heat transfer through direct contact. In the physics of survival, solid matter is your enemy. Imagine you are lying in a sleeping bag rated for -20 degrees. But you are lying directly on the frozen ground. The Earth is a massive thermal sink. Because the mass of the Earth is effectively infinite compared to your body, it will absorb your heat forever and never get warmer. Here's the physics trap most people fall into: compression. Down feathers and synthetic fibers work by trapping dead air. Air is a terrible conductor of heat, which makes it a fantastic insulator. But the moment you lie on your sleeping bag, you crush that airspace. Beneath your body weight, that expensive insulation becomes as thin as a sheet of paper. Via conduction, your body heat bypasses the bag entirely and dumps directly into the ice. This is why a sleeping pad is scientifically more important than the bag itself. You need a thermal break. In physics terms, we measure this with R value, or thermal resistance. Without that gap, conduction will drain your core temperature faster than the air ever could. If you sit on a rock, lean against a cold wall, or wear boots that are too tight, you are inviting conduction to kill you. Next, we have convection. When the air around you is still, your body heat warms up a thin layer of air right next to your skin. This is called your boundary layer. It acts like a tiny, invisible force field of warmth. Convection, or wind, destroys that boundary layer. It strips it away instantly, forcing your body to burn calories to heat a new layer, which gets stripped away again. This is the wind chill factor. It's not just a feeling, it is a rapid acceleration of thermodynamic loss. This is why shell layers in survival gear are critical. They don't insulate. They prevent the mechanical stripping of heat. But even if you stop the wind and you stop the conduction, you are still glowing. Everything with a temperature above absolute zero emits infrared radiation. Your body is constantly radiating photons of heat into the environment. You are literally glowing with energy. The problem is the night sky. On a clear winter night, the effective temperature of deep space is near absolute zero. If you are sleeping under the open stars without a reflective barrier, you are radiating heat directly into the cosmos. The clouds actually act as a blanket reflecting some heat back. But on a clear, beautiful, starry night, that is when radiation is most lethal. This is the physics behind Mylar space blankets. They don't insulate, they act as a mirror for radiant energy. If you ignore radiation, you're trying to fill a bucket that has a hole in the bottom. Now, we reach the most dangerous mechanism of all, the one that preppers misunderstand the most: evaporation. In physics, a phase change requires massive amounts of energy. To turn just 1 gram of water from liquid to gas takes about 540 calories of heat energy. Where does that energy come from? It is stolen directly from your skin. The old survival adage says, you sweat, you die. Scientifically, that is accurate. If you are hiking to your bug-out location wearing all your heavy gear, you will start to sweat. That water saturates your base layers. Water conducts heat 25 times faster than air. Suddenly, your insulation is useless because it's wet, and simultaneously that water is evaporating, pulling heat out of your core like a vacuum. This creates a death spiral. You feel hot, so you sweat. You stop moving to rest. The sweat cools rapidly, conduction kicks in, evaporation spikes, and your core temperature plummets. Within 15 minutes, you go from overheated to hypothermic. So, how does your biological machine respond to this physics disaster? It engages a protocol called vasoconstriction. Your brain realizes it's losing the war. To protect the vital organs, heart, lungs, brain, it shuts down blood flow to the extremities. Your fingers and toes act like radiators giving off heat, so your body cuts the line. This is why frostbite hits the digits first. It is a calculated sacrifice by your biology to keep the engine running. But here's the catch. As your muscles cool, chemical reactions slow down. Dexterity vanishes. You can have the best fire-starting kit in the world, but if your hands are frozen claws because of vasoconstriction, you physically cannot operate the lighter. You are watching your salvation, but you can't use it. Then comes the shivering. Shivering is your body's last-ditch effort to generate mechanical heat. It burns through your glycogen stores, your fuel reserves, at a terrifying rate. If you don't put fuel in, the shivering stops. And when the shivering stops, you aren't warm. You are dying. This is the stage of confusion, lethargy, paradoxical undressing. The brain shuts down. Okay, that's the doom and gloom. How do we use physics to survive? It comes down to a 3-part system designed to counter the 4 laws of heat loss. Number 1. Manage moisture. Your base layer must be hydrophobic, like polyester or wool. It moves water away from the skin to prevent evaporative cooling. Never wear cotton. Cotton kills. Number 2. Trap air. Your mid-layer is for loft, fleece, or down. Its only job is to trap dead air to stop conduction. Number 3. The shield. Your outer shell blocks convection wind and manages moisture release. But the most important piece of gear, it's not in your backpack, it's in your stomach. You need to treat your body like a wood stove. In freezing conditions, you need to consume high-fat, high-calorie fuel, specifically before sleep. Digestion generates heat. This is called the thermic effect of food. Fuel the furnace or the fire goes out. Survival isn't about buying the most expensive parka on Amazon. It is about understanding thermal regulation. It is about looking at a piece of ground and thinking, that is a heat sink. Or feeling the wind and thinking, that is convection stripping my boundary layer. When you respect the physics, the cold is manageable. When you ignore the physics, the cold is lethal. If you want to dive deeper into the science of survival and see us test these theories in real-world scenarios, make sure you hit that subscribe button. Don't let entropy win. Stay warm and stay safe.